Hello everybody, and welcome to session about an ML Toolkit using in bank. It is a co-innovation project with our partners InterSystems. First of all, I want to say a lot of thanks to InterSystems company for inviting us to this global event, and letting us to share our experience. Let me introduce our team today. He's my colleague Gulzahida Sadyrova. She is the head of Big Data Department. Sergey, Lukyanchikov, and Eduard Lebedyuk are sales engineers of InterSystems. And me, I'm a head of team of modeling and data analysis in bank. Today we will cover the following topics. It's about our company, the solutions were used in banks based on InterSystems products, our co-innovation project, ML prototypes of segmenting and forecasting, ML prototypes recommended payments using ML Toolkit, and some findings and next steps. A few words about our company. Let me give the floor to my colleague, Gulzahida.
Hi everyone. Firstly, thank you for coming to our session. My name is Sadyrova Gulzahida. I'm head of big data in Halyk Bank. I would like to say a few words about Halyk. Halyk means, in Kazakh language, means peoples. And we part of big group, which names Halyk Group. Halyk Group takes the third place in terms of assets in Central Asia. Halyk Bank, one of the part of Halyk Group. Halyk Group includes the banks of 6 different countries, and investment, insurance, and the collection companies different. Halyk Bank, the largest bank in the Kazakhstan. Halyk Bank, we serve 60% in retail. In retail business, we serve 60%. 60% of, sorry, just a second. In regard to the retail business, we serve 60% of all countries' population. Nowadays, we has launched a big digital transformation project in our bank, and we are starting to create new digital products, new digital services by applying innovative technologies. We used the machine learning to cross-selling, to increasing transaction activity, considering customer requests, and of course, the huge part is creating different recommendation system for good customer journey. Our priorities is customer experience, firstly, of course, and the stability and quality of our online services. And the part of our big transformation project is machine learning. We created with together with our partners, InterSystems company. And the detailed information of our project will tell you my colleague, Arman. Thank you. If you have any question, you can ask me.
Thank you, Gulzahida. We have been working with InterSystems for about 8 years. There are 2 major solutions in bank based on InterSystems products. The first one is our business process management system. It's our in-house project, in-house solution. The main function of this system is automation business processes. There are more than 200 business processes, such as unsecured loans, mortgaging loans, issue debit or credit cards, some customer statements, and many other processes in banks. The general landscape is on this slide. The front layer consists of a bunch of services that receiving requests from our presentation layer. And there are user portals, processes forms, internet banking, and third-party services, APIs, and other. The middle layer is a bundle of services too. We're using a Docker container, some CI/CD processes, and the core is based on Ensemble and Cache database. We implemented BPMN designer, which support BPMN 2.0 design notation, and this system was integrated with most of banking systems, most of core systems, transaction systems, and other. More than 3,000 users are working in these systems, and more than 35 million running processes per month. The second one is our payment gateway system. It's the single point of integration with third-party service providers. The main function is provide our customer payments through this system to our partner systems. The core can be divided into 3 logic parts. There are facade and core and adapters layers. We're using some Docker containers too in this system, and some CI/CD processes. Both of these systems generate a lot of data, and a few months ago we started co-innovation project with our partners InterSystems to get the benefit of this data. We choose the payment gateway to testing our ideas, and developed some machine learning prototypes. It's 2 prototypes. Let me give the floor to Sergey, who will tell more about these prototypes.
Thank you, Arman. So like Arman said, we have, hello everyone. So we have 2 prototypes. One is addressing so-called providers. Those are the companies, banking companies, retail companies, merchandisers that are processing payments from payers, from us. And the prototype that is mentioned on the screen refers to providers, the companies that work with Payment Hub as sort of distributors, so to speak, of payment services. So in this prototype, we are aiming to develop a solution to forecast the intensity of activity coming from intensity of payments, the volume of payments coming from providers. And with that, we applied 2 approaches, one of them called segmenting or clustering, also in a slightly more statistically centric language. This one allows us to group our audience, our provider audience, into statistically stable segments, regrouping those of them that are characterized by the characteristics that are common to them, so to speak. So in each segment, we regroup the homogeneous audience of providers. Some of them, for example, could be high volume but low frequency. Some of them can be high frequency, high volume, but very little cash flow per transaction, and so on. So in this, as you can see, I'm started to use that RFM paradigm, language, recency, frequency, and money. This is something that can be found in any marketing book, but before we can build our segmenting on it, we need to fill it with some concrete metrics. So for example, for recency, which is an abstract term, what is recency? So recency is, in human understanding, is how long and how persistent this provider has been doing business with us. But in machine understandable terms, that would be, for example, year, month, date, YMD minimum. So the earliest year, month, date, earliest date that this provider appeared in our transactions pool. Similarly, year, month, date, max is the maximum date that we have seen him actually performing transactions. The span between those 2 days is the physical, temporal span between the moment it appears in our history and it's finished. It performed the last operation in the history. Then we calculate the count of periods, which in this case could be days or could be months, actually days, that the transactions actually were taking place. So despite the fact that a provider could be active for 1 year, his actual activity could be confined to just 2 months. And then we calculate all sort of different relative numbers like density, how many active periods were there per his span, and so on. What we've done also, what we applied here to navigate from absolute values to relative values, and by this having a common basis for comparing of the positioning of those providers across different periods, we converted all those metrics to the so-called quantile measurements. In this case, we've chosen deciles. So we each value, for example, the span or the count of periods of activity, we have converted into a number from 1 to 10, depending on where and on which position that provider is in the distribution for the whole population. So finally, to calculate recency, we applied a linear formula here by applying some fixed experience-driven coefficients, which can be optimized further on, and that could be one of the points for improvement of the prototype. But currently, they are fixed by our experts from the bank. So with this approach, we also suggested an approach to calculate frequency and also money. So money, it goes about the amounts that are summary amounts for the lifespan, for the life cycle of that provider. That can be amounts per elapse of time and so on. So with that already, so what I present at that slide, that's a summary slide for both the process. So I'll allow myself to go slightly here just to show. So that's the analytical process in the system. That's how it looks. So those of you that are using ensemble would recognize a standard ensemble process. The only difference now is that it can call out the Python scripts. And those Python scripts are embedded in separate steps. We see that the process is linear, but we'll see in other examples that it can be non-linear. So many would find it useful to run several Python calculations in parallel, or do cycles, or do some sort of forks based on a certain condition. So in this case, we have an amalgama between what ensemble gives us natively with the force of machine learning scripting language, in this case Python. So in this table, running back, in this table we can see that all those metrics that you see actually depicted here, they are regrouped. So based on those metrics, we calculate recency, frequency, and money coordinates. And by applying a clustering algorithm, in this case, in this prototype, we've started by using k-means, the most straightforward and probably not the most efficient, but straightforward clustering algorithm. We have obtained the results that you can see in the upper part of the slide that present different projections. For example, you have in the left diagram, you have a projection on recency and frequency. The middle part is frequency against money, and the third one is money against recency. So as you can see from all different angles, that dot space has been dissected into more or less distinct segments statistically, and that allows us to do other useful things. That's not a result per se, but we can, for example, if we're aiming to build forecasts, so now basing us on each of the segments that we have calculated and looking at the unique profile of transactions volume that characterizes each of those segments, we can build more relevant forecasts. So to give you a preview of how it looked in the actual world, it looked like that. So for each of the segments, we do some data preparation in the beginning of the process, and then we are applying the ARIMA, actually SARIMAX variety of ARIMA approach, that is the time series analysis family of algorithms that is analyzing the historical profile of transaction volumes per cluster. There are 3 clusters, as you remember, so there are 3 branches further on that are calculated in parallel. And for each of those branches, there is a classical ARIMA analysis that is applied. So to speak, we extract the trend component, we extract the cyclical or seasonal component, and we are left with a noise of fluctuations in the end. Each of them modeled by separate formulas, separate methods. And in the end, when we combine them together, so we make a synthesis, we are receiving a forecast for a specific cluster for a specific channel. So we detailed this exercise not only per cluster, but within each cluster, we also build a forecast per payment channel. The payment channel is web banking, it could be ATM, it can be anything that the customers of Halyk Bank are using. So in the end, we end up with a space of 3 times 6 or 7, like 21 different forecasts that are built completely automatically and can be built in a loop. So in this case, we're testing it as a starting at once and then it ends. In production world, it can be looped and it can calculate in a more or less iterative way your forecasts. The second prototype, which Arman referenced to, is devoted to another audience. It's the audience of payers. Payers are people like us that are effectuating payments with a credit card or via a portal using Halyk Bank's payment hub as a platform. And as you will see it, despite the fact that the slide is the same, we're talking about, just in this exercise, just in that laboratory exercise, we are talking about 2,500,000 individual pairs. So we are analyzing transactions for, I think that was 3 years length per 2,500,000 individuals that were paying through their hub. And we did it with the purpose of actually suggesting a number of rules that would tell us per segment and theoretically further on per channel what the most probable baskets for those individuals would be. So a basket in our banking hub context would be the payment destinations. Like in this case, I pay for utilities. And I'm from segment 1, so I pay for utilities. There is a lot of probability I'll pay for phone and I'll pay for health services. If I'm from segment 2, I can be a younger individual, so I pay more for transport, studies, and for utilities, of course. The third segment could be a little bit more luxury people, and those pay phone, finance. They have finance to measure, to invest somewhere, and they're paying for shopping, for example. So to arrive to those baskets, what we do, we browse through the individual transactions. We had 12 million transactions in our training data set. We rebuild it in such a way that for each pair, individual pair, and for each individual transaction in terms of our analysis, and we have selected an individual month within an individual year, so that will be a transaction. We put together and we list together all the payment destinations that are coded here as a basket. So all the different types of payments that a concrete physical person have effectuated during a specific month is a basket, is a purchase. And further on, we are applying an algorithm that goes through all those individuals and their baskets to finally produce what we call the association rules. So an association rule is something that is composed of 2 elements. The antecedent, this is something that we know that has happened. And the consequent is something, the probability of what we are evaluating using that rule. So for example, a typical rule would be if utilities is in the basket, then phone, payment for your phone, would be in the same basket with the confidence of 96%. So we make a reference here to a metric called confidence. There are some other metrics too that are being produced by the a priori algorithm that we were using to analyze those baskets. But for the time being, we were mostly orienting ourselves at the metric called confidence. Having done that exercise that actually involved, as I said, first clustering of our 2.5 million individual pairs, and then extracting per each cluster, per each segment, extracting the rules that give us the rule of how those individuals form their payment basket, we have arrived to a result like that. So we have another analytical process that first does the clustering work, and it takes quite some time. And probably if we're left with some time during the Q&A, I'll launch it live here just to give you the look and feel of how it works. It produces for us a picture like that, and it may look like a child's drawing, except for the fact that each dot on that drawing is an individual. Yeah, there are 2.5 million individuals that are depicted here. And as you can see, they are also sliced in 3 quite distinct clusters. That gives us hope that if we further apply a priori to each of those clusters, to their baskets, we end up with relevant rules to actually to be used in the portal, in the payers portal that the bank has, and we will enrich that portal with those rules that will, if the individual wants, of course, will guide him by saying that, hey, if you are characterized by the cluster number that, and maybe with some other descriptors that can be taken from the CRM profile, then please, if you start paying for utilities, consider also paying for school and consider paying for your phone. Don't forget. So with that, like what it was mentioned by Gulzahida, we're aiming to improve the user experience of the people that working with the payment hub, and by doing this, we expect also some economic benefit in terms of increasing volume of payments. At this point, let me pass the token to Eduard to just say a couple of words about the tooling behind this exercise.
Hi. When Sergey told me that I have 5 minutes and only 1 slide to tell about ML Toolkit, I thought I'm going to cram all the buzzwords in 1 slide. So here we are. Okay. Sorry. We go another way? Yeah. So, yeah, we're using ML Toolkit, which is a separate thing from QuickML. I'm going to touch on that later. ML Toolkit is an open sourced, community-supported and community-driven bunch of projects which you can use in your AI ML projects. Here is how it can be presented. So we have Python, we have ObjectScript API on top of that, and most important of that all, we have an interoperability adapter. So when you're developing in BPL and you're drawing your business process, you can just add some Python code or some R code, but that will come later, and it will just work. But you're not only interested in Python, right? What's the main interesting point? It's libraries, and we support all of them. Isn't it great? We support Pandas, Sklearn, here's the buzzwords, TensorFlow. Everyone heard of TensorFlow? Please raise your hand if you heard of TensorFlow. I see a lot of hands here. Great. Matplotlib. Now for R. Text2Vec. MLAR. ggplot2. It's a great library. So for R, we have a similar architecture. We have R. We have ObjectScript API, which you can use directly without interoperability if you're running that kind of thing. And we also have an interoperability adapter. So, yeah, that's what it looks like. It's available on OpenExchange. There would be a link later in the presentation. And in your event app, you have PDFs, which you can download and follow it later. And it's different from QuickML, which Don and Alex presented today. which aims to give a power of data science to developers, to subject matter experts. And ML Toolkit is a bunch of extensions which you already can plug and play and leverage R and Python languages in your projects. And with that, I'm giving the mic back to Arman. Well, I'm giving the mic back metaphorically because I got here last. So I'm with questions mic, which you will use later, hopefully.
Thank you, Eduard. A summary of findings from these co-innovation projects. These projects is all about testing ideas. It's all about innovations, co-innovations. Both of systems are generated a lot of data, huge volumes of data that need to be limited, sampled, actualized, and well so way before being sent to AI ML. We need to improve some of our data. We need standardization to represent object or person in uniform and unique way to reduce some noise in our models and prototypes. Ensemble let us make robotization a natural choice, and process can be implemented as agents that run each at their own pace and interact with others. Using Python scripts with InterSystems helps us unit strong features of both and unlimited coverage of mathematical functions by Python and native in database processing. What's the next steps? We're going to deploy our scenarios on data in sufficient quantity and quality and obtain first systematic results. We're going to ensure that business owns these prototypes, models, from the moment the deployment begins, validates the results, and applies the mechanism on a regular basis. We need to establish criteria to measure the quality and economic impact of this activity. We're going to use this toolkit in our toolbox and launch our team to research on, improve, and support these tools and prototypes. As said, Gulzahida, we are building some recommendation system to improve our customers' experience, and we are going to use both of these models. I think it will be an ensemble of models. The ensemble of models, we're going to use both of models in this ensemble, and when we applied this, we expect to achieve 30% increase in payment services sales revenue. Before we finish, let me give the floor to Sergey.
Thank you, Arman.
Thank you.
So just for those of you that would like to have hands-on on your own, Eduard mentioned it, but we're just visualizing it here. There is a marketplace, the open source marketplace of InterSystems called OpenExchange, and we have actually 2 pages there, 2 package pages, one for the Python package that comprises ML Toolkit, the package called Python Gateway, and Eduard is actually the developer of it. There is another stack, another package called R Gateway, and that one works with R. So for those of you that are tomorrow for our another session with another customer from healthcare industry, so that customer is using that other stack with R language. We have another number of links in that presentation that will take you directly there. Those presentations will be available from the event's website. For those of you that would like to join the already existing user community of the customers and partners that are applying this ML Toolkit already, we invite you to send us a quick email to mltoolkit@intersystems.com. In email, because the GitHub repo we have to bring people together in a user group is a corporate private repo. So everything that is discussed there is private. And to join it, you need to signal us using an email. That's the only reason that we're using email. Otherwise, it will be a link. And for those that are fine with just testing it quickly with a couple of examples, some of them already delivered during the experience lab by Eduard, some of them not, you are welcome to join for Python Gateway. There are a number of samples that are publicly available via a public GitHub repo. So please take that into account. As I said, tomorrow, just to give a little bit of information about our tomorrow's sessions, we have another experience lab here. And at noon, we have another presentation of this format that we have today with another customer representing healthcare industry, slightly different language stack. As I said, it is going to be R. And again, we'll discuss slightly different cases there, but all of them having a common denominator with what we discussed today. That's the tooling that is embedded in the IRIS platform and allows you to bring in one focus your processes, your data, your machine learning IP, and to use it efficiently. So with that, probably I would suggest we go to Q&A, but as I promised in the beginning, we're left with slightly more than 10 minutes. So I would take probably a couple of minutes to show something live, and we'll launch that analysis in the system, and while it will be running, we'll be taking questions. So, just to set the scenes, so what we see here, we see an empty table for the rules. So those rules that we discussed in the slides that need to be extracted by the analytical process from the data, first doing the clustering, then applying the a priori to analyze the baskets, and finally the rules should go there. So this one is empty. So this is the process that is going to do the work. There's one step that is grayed out because the data, all the necessary ingredients have been already uploaded to it, but it still has to do the Python work. So it will start from importing Python modules and go all the way through that process. And while it's working, if you're interested, we could do some comments as to how this process is built. And to make it work, I go to my production. There are several prototypes, and you see each of those processes, it represents a several prototype, but I'm using the affinity analysis here. And I'll just launch it. It will take approximately 6 minutes to accomplish. Please don't forget there are 2.5 million individuals, and it will go through 3 clusters to do the individual a priori analysis, so it will be running for approximately 6 minutes. And while it is running, I would suggest, please, if you have any questions, either related to ML Toolkit or to methodology or to the bank's experience, please step up and ask. Well, there may be some time needed to formulate. Since I've started that and it's running, maybe I'll be telling the story about the process and maybe explaining a little bit how this tooling works. And in the meantime, if someone thinks of a question, just feel free to walk up. We'll stop for a second and let you ask the question. We'll answer it and continue. So, so this step is easy. This is importing the Python libraries that we need for the work. And if I click that magnifying glass, I'll just see the Python scripts that brings in everything I need. I have NumPy, which is an ingredient in almost every analytical process. I have matplotlib, same thing for doing the graphs. sklearn for clustering. I have pandas to work with data frames. So all that stuff, the pre-processing to calculate my deciles or percentiles in the case of this particular prototype. And we have ML extender to do the a priori. So then, when I need to apply those algos to data from within that process, I'm uploading using a specific request that has been built as part of this Python gateway instrumentary.
I have a question.
Sure.
Okay.
Yes,
I was impressed that you started with metrics to whether it was a success or not. Could you talk about how you chose those metrics?
Well, I'd say it's been a bit of a brainstorm. We didn't find it black and white anywhere. We had to work with the business experts on the bank side first of all. We had to before going directly to that stage. We had to spend several weeks actually looking through the data, observing do we need the whole lot of data, or we will be fine with some frame. Within that frame, if we apply clustering, and clustering would need some dimensions, do we need all the possible attributes in that soup, or we just be fine with 3 of them, or 4 or 5? And at the end of that, I would say, rather negotiative process. So we came up with, first of all, that RFM paradigm that seems to be easy enough to explain to the people that are not data scientists. And then within, of course, once we accepted RFM, we needed to decipher what's R, what's F, and what's M. And with that, we suggested something that made sense and could be easily calculated based on the customer's data. So please, if other questions, just walk up, and I'll waiting for what I've launched to finish. I'll just continue explaining here that we have to load the data from cache. We're using a number of specific requests that we've added to standard ensemble. So one of them is called query request, as you can see here. And to make it work, we have to print in or type in here the query, the SQL query. This SQL query is thrown from within Python's process, is thrown to IRIS, to cache, and the data is being returned to IRIS, but returned already as a data frame. That's the specifics. Please, sir.
Good afternoon. How is the data ingested into the InterSystems environment? We talk about the data. Where did it come from? Is it back office data? Is it imported in through an ETL? How does this transformation take place? Because we're talking about a lot of data. So
Right.
if you could give us an explanation about how you evolved into the InterSystems environment and what leveraged InterSystems over something like the other databases that exist. Does that make sense? Is that a good question?
Sure. Thank you for the question. Eduard will answer it. I'll just mention that we will not show them live because some of them are still not sanitized. But
Why you went away? We could have like a quasi-rap battle here with one mic. But in this exact scenario, the data was already inside InterSystems, Ensemble in this case, or InterSystems IRIS. But if you're asking for the other scenarios where the data is outside, right? We have many ways to gather the data, and I guess the most interesting question would be: do we want to have a real-time copy, or do we want a sort of a copy once in a while? Because if we are satisfied with only getting a copy once in a while, it's fairly easy. We're using ATL, which is available in InterSystems interoperability. And if we want real time, we'll probably have some more challenges to solve, but it's also possible. And I think it would be determined by the exact nature of algorithms we are using, because sometimes we need an answer immediately for questions which arise in real time. And sometimes we need to use AI, ML algorithms to do a more long-term strategy to help us find a more long-term answers. And in that case, it can actually be easier for us to get the data because we don't need it as often.
I would add to that, in concrete terms of the bank, let's imagine it's a fully functional payment hub that is working 24/7, and they couldn't give us access to their production environment to start doing this. But luckily, they had a testing sandbox, and in that testing sandbox, we have asked the bank to transport, like I said in the beginning, around 12 million transactions, individual payment transactions with the date, the origin, the channel, all the attributes that are there. And we've been working, building those prototypes using that wealth of data, but trying to keep in our mind that that would probably be a gliding window of visibility on the data. Probably in the production, we will not need all that huge volume of data. We would probably be working with samples and so on. So to wrap it up, it's currently it's a sample, but large enough to simulate even the kind of productive functioning. And by productive functioning, I mean that we have a certain window that is gliding through the history as the history is being formed, and we're not working with the whole lot from the beginning. Hope we answered that. So while we were discussing it, our algo, it finished working. So you see the rules. Let me hide this one. You see the rules. There are different metrics, including confidence, that are being calculated by this particular Python package that is graciously available to us via the open source service. And those rules are calculated per cluster. So this is cluster 0. If I scroll it down, there's cluster 1, there's cluster 2. There are not too many. There are like less than 100 or around 100. And that's because we configured the algorithm in such a way that only the rules that have a confidence above a specific level are being accepted into the table. Because from that table, the user portal, the payer portal, is supposed to ingest those rules and do suggestions and suggest payments to a payer. All right. So there shouldn't be many. They should be confident, and they should be making business sense. We're left with a couple of minutes, and please, if any other questions, please ask them. Otherwise, I would refer us to this visual log. So every step in the process that we were looking at previously is logged here together with the Python part of the overall Python content that is being thrown to Python. And in case Python is supposed to return to us something, and that's something that happens closer to the end. Let me go to that. Yeah, this one. So for example, yeah, the rules per cluster, this is something that Python returns, and we have them in JSON format. So this is something we can see what has been sent to Python and what Python has returned. We can see it in the log. A couple of words about the functionality here. So we've looked at the SQL request, so that brings data into our process from IRIS or cache context directly into the Python's processes context as a data frame. So you don't need to format it. You don't need to explain to Python what it is. It's just pre-formatted for Python to read it. We have execution requests that are sending Python, or R in case of R, a piece of code that corresponds to that stage in the process to Python. We can, let me take one of those examples. We can, by sending a piece of code to Python, we can also request a data frame, some variable. It can be not necessarily a data frame, it can be actually anything that Python is carrying in its context. We can request it back into IRIS's context. Actually, there is a specific type of request in this instrumentary that allows us to take a snapshot of the whole context of the Python process. And all the variables, all the objects that Python carries till that moment in the process will be stored either as a global or in any other format. So in this case, we are requesting a specific variable. So for example, rules2 is a data frame that already contains the association rules we were hunting for. And it returns us that variable using JSON serialization. We can use streaming serialization. We may be not using serialization, we can return it as a simple text. If in case Python is carrying it in its context, in its context as a simple text. And in the end, we're at the end of our time, and in the end, we are applying a little bit of object script. So we're doing from that variables that are being sent into Iris's context from Python, we are browsing them using object script, and we are filling the contents in the resulting table. So with that, we are at the end of our today's presentation. Thank you very much for your attention. Join our user group.